The Scuba Pro MK25 is a flow-through piston design delivering seamless airflow at any depth, equipped with a 5-port 360 IP swivel plus 2 HP ports offering endless hose configuration. Within the MK25 family, we have several different metal offerings including titanium, SA, stainless steel aluminum alloy, and robust chrome-plated marine brass. Most models are offered in DIN configurations as well. During this presentation, we will cover all aspects of a typical annual service including disassembly procedures, general cleaning and inspection, reassembly, and final adjustments and testing. This tutorial is intended to assist you and further support the tips, techniques, and subject matter covered in the Scuba Pro workshop. Prior to servicing any first stage, we recommend checking the intermediate pressure and lockup characteristics, as this data tells a story and must be taken into consideration. The IP range for all Scuba Pro first stages is 125 to 145 psi. Once IP and lockup characteristics have been verified, we are now ready to begin disassembly. To properly service the Scuba Pro MK25, the following tools are necessary. Some variation of these tools is acceptable, providing they are equally suited. Scuba Pro multifunction tool with comfort handle, 22mm socket. A 6.1-inch socket is best to remove the yoke retainer. 7/32 Allen adapter. Field handle to brace the first stage. Soft brass tool set. Bushing system tool. Piston bullet. And torque wrench. Always reference a current schematic and tech notes taken during your specialized Scuba Pro workshop. Let's get started with the disassembly section. Remove all HP and IP port plugs, including the 5th one on the bottom of the swivel. The usage of a vise is always best. Engage the field handle into the high pressure port for maximum holding strength. We begin by loosening the yoke retainer, engaging the 6.1-inch socket plus extension and loosen. Rotate the first stage and remove the cap, then engage the 22mm socket with corresponding extension to loosen the high pressure seat retainer. We can now move back to the bench. Finish extracting associated parts from the yoke retainer, including the O-ring, vented saddle, filter retainer, and filter, utilizing a brass pick. Remove the loosened high-pressure seat retainer featuring external IP adjustment completely, plus sealing washer. Now advance and remove the adjustment set screw for cleaning purposes and re-lubrication. This now exposes the metal friction disc and static O-ring. Secure the field handle into the first stage HP port. Now position the multi-tool spanner at a 45-degree angle for maximum control and loosen the piston cap. Position the first stage like so, in preparation of separating the piston cap from the main body. Once the piston cap threads are disengaged, lift the cap with an exaggerated motion to protect the end detail of the piston. Corrosion buildup will determine if the piston remains behind in the main body or follows the piston cap. As in this case here, the piston has been left behind. Grasp the piston together with the spring and with an exaggerated motion, remove, being careful to protect the end detail of the piston all the while. Where the piston stem travels through the main body, push the high pressure seat outward using the soft brass fin tip end. Watch for the retainer spring to drop out as well. Now switch over and use the pointed soft brass pick to remove the MK25 bushing system. Simply follow the cylinder walls and expel 2 bushings and O-ring. Remove shim. Undress the piston. Remove the TIS silicone sleeve. Note that units built as of 06 will have 2 sleeves, one surrounding the other. Now remove the 2 piston head O-rings and separate bushing. Leave the O-ring at the base of the stem in place, as it receives little wear and tear and rarely needs replacement. The 5-port swivel is held together via a retainer. Engage the field handle and insert the 7/32 Allen adapter like so and loosen counterclockwise. Retire the tools and hold the retainer in place with your index finger and rotate the heavier component to facilitate this operation. Once the retainer is out, search for the friction washer as well. Now remove the swivel O-ring like so. We are now ready for the general cleaning section. The first stage is completely disassembled and ready to be cleaned by placing the separate components in the ultrasonic cleaner using a suitable solution. Place all parts into the stainless steel basket. Isolate any delicate parts to protect them from damage. In this case, a 35mm canister works very well to isolate the piston knife edge. We are now ready to dry off the parts, further clean, and general inspection. Dry off components with air, clean shop rags, towels or paper towels, and cotton swabs. Just be sure they are clean and dry each time. Detail the piston knife edge using a common pencil eraser. Utilize light to your advantage to detect any imperfections in the knife edge. Use of your fingernail will aid in determining the extent of possible damage. Here you will note that we have a shine or bright reflection. However, there is a dull point which will require further inspection and will more than likely merit replacement. Apply a speck of lubricant to your fingertip and inspect the overall integrity of the compression chamber wall finish. Let's cover proper lubrication for each application. In that this is a dynamic O-ring land, we must distribute a bead of lubrication 360 degrees. Work the lubricant into the pores of the O-ring, feeling for any imperfections which can be detected by your fingers. Install the friction washer onto the swivel retainer and lubricate the end starting threads. Hold your index finger at a 45-degree angle, hand tighten components, and introduce associated tools. Let's move over to the vise, brace the unit, and torque properly. Set the torque wrench for 70 inch-pounds and or 8 Newton meters. See current schematic to cross-check and verify the current value. Ready to assemble? In that this is a dynamic O-ring land, distributing an even bead of lubrication 360 degrees is appropriate. Work the lubricant into the pores while running an inspection. Feel for any imperfections which can be detected by your fingers. Install and press the O-rings flush into the lands. Return the bushing. Lubricate the TIS sleeve and slide into place. One surrounds the other. A general inspection to note that the O-rings are indeed captured and that the air access flat is in our line of sight. Double check that O-rings are pressed in place, return the piston cap, and rest. Now proceed using the main spring in an effort to apply uniform pressure, guiding the piston into place to avoid O-ring pinch. Once installed, remove the spring and visually inspect for O-ring pinch. Any degree of pinch merits replacement of affected O-rings. Proper order or series of the bushing system components is absolute. The bushing system is comprised of 3 components in series. Begin with the stepped bushing first. The step is a spring pad. Apply, or pack if you will, generous amounts of quality lubricant between the series of components like so. Second, install the piston stem O-ring and generously lubricate the O-ring and area. Third, add the bushing with the 4 blind holes, which faces away from the stem O-ring, providing a smooth surface for the O-ring to rest on. Install the properly stacked bushing tool into the main body. Once the tool has bottomed out, visually check the end to confirm that the tool tip is flush with the piston stem female cylinder. Once this is established, begin rotating the tool back and forth to break the tool away from the installed parts and slowly extract the tool, leaving the parts behind in place. Rotate the bushing tool to the opposing open end and reinstall until the tool bottoms out. This will hold the bushing system in place. Return the shim and spring to the main body. Insert the piston bullet into the piston. This will avoid possible damage to the piston stem O-ring during installation. Add some lubricant to the male threads on the main body. Grasp the piston and cap assembly and insert into the main body. Tighten by hand. Now you may release the bushing tool and retrieve the piston bullet. Look carefully to be sure the bushing system is in place. If the knife edge picked up any lubrication, wipe it clean with a cotton swab. Lubricate the high-pressure seat O-ring and install. It's good practice to flip the high-pressure seat to the back to ensure that we not get lubricant on the usable face of the seat. Generously lubricate the adjustment screw and back it into the seat retainer. The lubricant obstructs water entry until the next service. Now secure the bushings in place with the retainer spring. Then press the new HP seat with new O-ring in place, facing the concave side towards the knife edge. Use of a suitable tool to push evenly is okay. You should encounter some spring action. Install the retainer base 147 O-ring into the body, chase as necessary. Reinsert the metal disc locating the centering pilot guide into the back of the high-pressure seat. Look for the plus sign with center cavity. Return washer to the high-pressure seat retainer and grasp and align with your fingers. Install a new filter and filter retainer into the yoke retainer, convex towards the filter. Press secure with suitable device to the point that no rattle is present. This ensures that the gas passes through the filter instead of around it. Place the dressed retainer into the yoke followed by the saddle, 138 O-ring, and orient the saddle flat edge towards the ambient chamber and snug down with the multi-tool. With feel handle attached to the HP port, secure in vise. Engage the 6.1-inch socket, corresponding extension, calibrate, and attach the torque wrench tightening to factory specification as noted in the current schematic. Equip all port plugs with new O-rings. As the plugs are small, the use of an Allen key set can come in handy. Spread the dust cap over the yoke. Return the yoke screw to the yoke or A-clamp. We are now ready for the final adjustments and testing section. As with all Scubapro balanced first stages, IP should be checked at both 500 psi as well as 3000 psi supply pressure. Let's begin with 500 supply pressure as a starting point. Remember to always depress the purge valve while charging the first stage with high pressure air, keeping a watchful eye on the IP gauge, slowly backing off on the purge valve until lockup is established. In this case, we can observe that with a supply pressure of 500 psi, our IP is above the Scubapro range of 125 to 145 psi. As the Mark 25 features an external adjustment, making IP adjustments is simple. It is important, however, to turn the supply pressure off and purge the system completely. Advancing the adjustment half a rotation at a time clockwise, the IP is now in range. The next step is to increase our supply pressure to verify or witness any changes in IP. An IP inversion of approximately 1 to 5 psi can be expected and anticipated, however is not always the case due to individually machined parts. The final step is to return the cap by simply pressing it into place with a snap. The objective of this presentation has been to give you a real-world practical approach covering all aspects of a typical annual service, including disassembly procedures, general cleaning and inspection, reassembly, and final adjustments and testing. Now that your customer's regulator is finely tuned, call and tell them they're ready to continue exploring our amazing underwater world.